we introduce Multi3DRefer, grounding text description to multiple 3D objects. Existing 3D visual grounding tasks focus on localizing a unique object given a text description. We argue that such a strict setting is unnatural, as localizing potentially multiple objects is commonly necessary in real-world scenarios and robotic tasks. Datasets in prior work also contain ambiguous sentences for which multiple objects can satisfy the description, despite prior work assuming only one target object. To address this limitation, we generalize the scan-refer dataset and task and propose Multi3DRefer, localizing a flexible number of objects given a text description. Multi3DRefer has a new dataset with more diverse data, a more generalized task with a new evaluation metric, and a better baseline method for addressing the task. We augment the scan-refer dataset to create our dataset with descriptions which match either zero, single, or multiple target objects in the scene. To efficiently generate this data, we design a data construction pipeline. To obtain zero target data, we establish negative pairs of scenes with existing descriptions randomly select from other scenes. For single target data, we directly get them from the scan-refer dataset. And for multiple targets data, we randomly select descriptions and trim the text to the first punctuation to obtain shorter and more ambiguous descriptions. Finally, to get higher quality and more diverse data, all three types of data are sent to ChatGPT for sentence rephrasing, followed by human verification and modification. With this dataset, we introduce a new evaluation metric for studying the Multi3DRefer task by evaluating models under 5 separate scenarios, where a distractor is defined as an object having the same semantic label as the target object, even though the description ultimately does not apply to it. To address the task, we follow the detect and match architecture from prior work and propose M3DRef clip. It first detects object proposals in a scene. Then it renders online multi-view images for each proposal and feeds them to an image encoder. The outputted 2D features are concatenated with 3D features from the detector as the final feature vector for each object. For the language module, it encodes a sentence first, and then the outputted sentence features are used with the concatenated object features for contrastive learning. We choose clip to serve as both text and image encoder. The final object and word features are then fed into a fusion module to calculate a confidence score for each object proposal. We systematically evaluate our method on both scan-refer and Multi3DRefer tasks. Our method achieves the highest performance on both two tasks compared to prior work. Here are some qualitative results of comparing our method to a prior work D3net on the Multi3DRefer task. Our method outperforms prior work in all three scenarios. More examples of Multi3DRefer datasets are shown here. Thanks for watching, and please refer to our paper for details.